Now let's use the Cartesian plane to show the changes that took place in the former case we had. That is the volume of petrol in the vehicle and the distance the vehicle travels before the volume of that petrol finishes the process. This table here reminds us of that which we had in the beginning. Recall that when 2 liters of petrol were put into the tank, that the vehicle traveled 4 kilometers before the petrol got finished. The same thing applicable to 4 liters, 6 liters, 8 liters, and then 10 liters. So the volume of the petrol determined the distance that was to be traveled. Because of that, we refer to this volume as the independent variable and this distance as the dependent variable. Correspondingly, we use this axis for the independent variable. It means that though we have labeled it x here, the x represents all independent variables. Therefore, if this plane is to show a real-life situation, what I should have written here is the v. But as it were, because we're approaching it from pure mathematics, I wrote x here. Likewise, this distance, which is dependent variable, should have been written here, but instead, plus y has been used, or just y has been used, because y represents all dependent variables. If you watch this plane, Cartesian plane, you observe that it is not the 4 sections that have been used. It is only this positive y and this positive x that are being put to use. Why? If you watch the table with which we want to practice using the plane, you realize that this volume is all positive. There is no negative volume. Because of that, we will not make use of this side. Likewise, all distances are positive. Because of that, we're not going to make use of this negative side of the y. In fact, that we have seen 4 here without a sign before it means that it is plus. Don't forget the foundations of mathematics. Therefore, we de-emphasize the use of this side and this side, then emphasizing the use of this axis and this axis. Let us now focus on both of them as we use the axis to show changes taking place between the volume of petrol and distance traveled. Now, if you watch the volume, you see that the highest volume that was used for the experiment was 10 liters. Look at the 10 here. All changes began from 0 liter to 10 liters. How come these values 1, 2, 3, 4, 5 to 10? In fact, time has not arrived for us to know how these numbers came, but before then, I want to tell you just one thing. Notice that I did not just lift values from this column and paste them on this axis. I had to write these values 1, 2, 3 based on a system that we'll learn later, a system of choosing scales. Just know it that from 0 to 10, 10 is here the highest value of the volume used. Then from 0 to 10 is measured and broken into equal intervals. That is why if I must break it from here to here into 10 divisions, it thinks that one division of one interval is 1. If I should break from here to here into 5, it thinks that each of the 5 divisions will be 2, and so on and so forth. Later we'll learn how to break the axis from 0 to the highest value to be shown on the axis into equal divisions. That process is what we'll refer to as choosing the scale. Time has not come for us to learn that one. When it comes, we learn how to make use of formulas for finding the scale for use. Notice also that this distance, which is plotted or which is shown on this axis, does not show lifting 4, 8, 12, 16, and 20 directly into this axis. As you can see, I have 4, 8, 12, 16, 20. How was it done? In a similar way, the highest value is 20. If 20 is here, then from here to here has the distance. If you break this distance into 5, then each division, like from here to here, should be 4. Here to here, another 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 4. If from this 20 to this 0 should be broken into 20, it thinks that each division should be 1. That is 1, 2, 3. That means you're going to need more space to accommodate this 20. That is why I did not make it 1, 1. The space from here to here is so small to be broken into 20 equal divisions. If I should choose to break it into 4 equal divisions, that is from here to here, then it means that each division here called interval will be equal to 5. So that from here to here will be 5, another 5, another 5, and so on. Just know it that we use the highest value we are going to plot to know the value that will be corresponding to each interval. When time comes, we practice that in full. But in the meantime, just know it that we don't just lift values from table into the axis. Instead, we break each axis into equal divisions so that each division will correspond to a value. Right now, let us see how to see changes taking place between the volume and the distance with this axis, with the two axes on the plane. This volume, which is 2 liters, is here. And the distance is 4. That means that the D is 4 and the V is 2. That is this 2 and this 4. What will happen is that we're going to see a place where both of them meet in space. If a line is drawn vertically upwards from these 2, and a line is drawn horizontally from this 4, the place where they meet is called spatial point of intersection. In a place like this, let me draw a sign to show that this place is a place where both of them meet. Again, I call it spatial point of intersection. Let's see. Yes, see, this is a sign that shows that this is a place where the 2 and the 4 meet. That is how to trace the spatial point of intersection. Now, let us proceed to the next one. When V is 4, that is when V is 4. Recall that this line is for V, though it is labeled X here. 4 also, while going up vertically, will meet 8, going rightwards horizontally. That means that 4, a line taken vertically upwards from 4, will meet a line taken horizontally rightwards from 8. Whatever they meet is also called the spatial points of intersection. Let's see. Again, see where the 4 and 8 have met. Let us see where 6 and 12 will meet. This is where the 6 and the 12 meet, like this, and then this way. They meet here. Let us see where 8 and 16 will meet, and also where 10 and 20 will meet. Now see where the 8 met 16 and see where 10 met 20. The next thing is to fix a line of best fit through these points with a meter rule. Let's try and do that. That's great. This is the line of best fit. This straight line is called the line of best fit. It cuts across the 5 points. Anyway, this is not always obtainable. What I mean is that it is not always possible to have this straight line pass through all the points, especially because it is human to make mistakes. It is just a coincidence that this straight line, otherwise called line of best fit, pass through all these points. You can agree with me that this straight line is beautifully drawn. The beauty is not what matters here. What matters to us here is what that line and what the entire arrangement represent. Just at a glance, with this sketch of changes taking place between the volume and the distance, you can check other volumes which are not shown in the table and the corresponding distances they can make the vehicle move. Take, for instance, if we have known before that these 2 liters will make a distance of 4 kilometers, and a volume of 4 liters will make a distance of 8 kilometers, and a volume of 6 liters will make a distance of 12 kilometers, and a volume of 8 liters will make a distance of 16 kilometers, and ultimately a volume of 10 liters can make a journey of 20 kilometers. These are the only ones that were found in the table. But with this sketch on the plane, we can estimate the distances that other volumes not shown in the table can travel. Take, for instance, if the owner of the vehicle puts 3 liters of petrol into the vehicle, how do we know how much distance it is going to travel? It is estimated by moving a line vertically upwards from this tree to meet this straight line. Wherever it meets it, then draw another line horizontally going towards the y-axis. Whatever it meets it, then a value corresponding to the place where it meets it is the distance it will travel. So maybe here between 4 and 8 is around 6. That means that, let's say for instance, 3 liters of petrol will make a distance of around 6 kilometers. What about a distance of 5 liters? What about the volume of 5 liters? Let's try to estimate the distance it will travel. Again, you move vertically upwards from this 5 to meet this line, and when the line is met, then move horizontally towards the y-axis. We can meet between 8 and 12. Between 8 and 12 is 10. That means that approximately anybody that puts 5 liters of petrol into this vehicle is expected to cover a distance of 10 kilometers. How beautiful this sketch is. Checkpoint number A, it says, given the following marked positions on straight lines, divide each line into 4 intervals, 5 intervals, 10 intervals, and calibrate accordingly. I believe you understand this instruction. These are those lines: line I, line II, line III, line IV, line V, and line VI. What it means is that when you come here to this line I, divide from here to here into 4 and calibrate. The same into 5 and calibrate. The same into 10 and calibrate. Do the same thing to all other ones that come after it.